Light moves at an absolutely blistering speed. We interact with it constantly, every single day, but we rarely stop to think about why it behaves the way it does. And here's the thing, the deepest mystery in all of physics isn't just how fast light travels, it's why this specific speed is the ultimate unbreakable boundary of our entire reality. In a vacuum, it travels at exactly 299,792,458 meters per second. That's right around 300,000 kilometers a second. To put that into perspective for you, a single photon could zip around the Earth more than 7 times in just 1 second. But, we've already measured that. The real question we need to answer is a lot more profound. Why this exact speed? Why not just a little bit faster or, I don't know, slightly slower? And most importantly, why is this an absolute cosmic wall? Why can't anything, no rocket, no particle, absolutely no information ever outrun it? Well, to figure that out, we actually have to look at what light itself is. Back in the 19th century, James Clerk Maxwell completely flipped the script on physics. He proved that light isn't just a simple beam, it's an electromagnetic wave. It's this continuous, intricate dance where changing electric and magnetic fields actually create each other. And the craziest part? His math showed that the speed of light, what we call c, is entirely dictated by 2 fundamental constants. Basically, the electrical permittivity and magnetic permeability of a vacuum. These are essentially the built-in resistances of empty space itself. So light speed, it's literally a built-in property of the universe. Now, this completely shatters our traditional view of empty space. We usually think of a vacuum as just nothingness, a total void. But modern physics paints a wildly different picture. The quantum vacuum is not nothing. It's actually this highly dynamic, structured environment that is constantly bubbling with quantum fluctuations. We're talking about ephemeral pairs of particles and antiparticles just popping into and out of existence in a tiny fraction of an instant. And that bubbling vacuum leads us to a really fascinating theory about why light travels at the exact speed it does. Some physicists, like Marcel Urban and his team, suggest that light's finite speed is essentially caused by a kind of cosmic leapfrog. Imagine a photon cruising through this quantum vacuum. It's not just an empty highway. It gets intercepted, it gets grabbed by these ephemeral quantum particles, held for a microscopic split second, and then released. If it weren't for this constant catch and release game by the vacuum itself, the photon's raw underlying speed might actually be infinite. The vacuum acts almost like a microscopic obstacle course that sets the ultimate speed limit. Okay, so we know why light travels at the speed it does. But what happens if you try to outrun it? What's physically stopping us from building a massively powerful spaceship, hitting the gas, and just pushing past that 300,000 kilometers per second mark? Well, Einstein's special relativity steps in and ruins the party. As any object with mass approaches the speed of light, things start to get seriously weird. The amount of energy you need to accelerate just a tiny bit more, it skyrockets toward infinity. And it gets crazier. To someone watching you fly by, your flow of time actually slows down. It literally grinds to a halt. On top of that, your physical size in the direction you're traveling shrinks toward zero. Now, since photons of light have absolutely zero mass, they get a free pass. But for you, me, or a giant rocket, that speed is a mathematical brick wall. And as physics professor Christopher S. Baird brilliantly points out, this isn't just a physical barrier you can eventually punch through with enough force. Speeds beyond light literally do not exist. It's exactly like asking what's colder than absolute zero. Space and time themselves cease to exist at that mathematical point. You literally cannot shrink to smaller than zero, and your clock can't tick slower than stopped. The whole concept of faster than light is just a nonsensical question in our physical reality. Right, but I know what some of you are thinking right now. What about loopholes? What if you take a super powerful laser pointer, aim it at the moon, and just rapidly flick your wrist? The moon is huge and really far away, so that laser dot would sweep across the lunar surface in a fraction of a second. Doesn't that dot travel faster than light? It totally seems like a paradox, but it's not. You see, the laser dot isn't actually a single physical object. It's an illusion. It's just a sequence of completely different photons hitting adjacent spots on the moon, one right after the other. Think of it like the point where the 2 blades of a pair of scissors cross. That intersection point can move incredibly fast, but the actual metal blades aren't exceeding any limits. Because the laser dot isn't a single thing, absolutely no mass, energy, or information is actually traveling from one side of the moon to the other faster than light. And this brings us to an incredibly crucial distinction. Calling it the speed of light is actually kind of misleading. We really need a vocabulary upgrade here. What we're actually talking about is the speed of causality. It is the absolute maximum speed at which any cause can produce an effect, anywhere in the universe. Think about it. If our sun just vanished right now, we wouldn't even know it, and Earth would keep orbiting normally for about 8 minutes. Why? Because changes in gravity are bound by this exact same speed of causality. So what if we could somehow break this rule? Let's say you invent a sci-fi hyperspace device and send a physical message faster than the cosmic limit. Well, you wouldn't just be going fast, you would be fundamentally breaking causality. Because relativity means observers moving at different speeds experience time differently. A faster-than-light signal to one person actually looks like a message traveling backward in time to another person. You could literally receive a text message reply before you even hit send. It would trigger massive reality-breaking paradoxes, like the famous grandfather paradox, and logic itself would completely collapse. Okay, bringing it back to our main mystery. If the speed is the fundamental bedrock of reality, why on earth is the number so incredibly ugly? 299,792,458 meters per second. Why couldn't it just be a nice, clean 300 million? Well, the truth is that messy number is entirely our fault. It's a human artifact. We measure things in meters and seconds, but humans invented those units centuries before we knew anything about how the cosmos actually works. I mean, if we just made up a new unit of distance and called it the, optiodometer, we could mathematically make the speed of light exactly 13 if we wanted to. While the underlying physical constants of the vacuum are still a profound mystery, physicists actually fix this clunky human math by using something called natural units. In natural units, we strip away all our arbitrary human measurements. The speed of causality is defined simply and perfectly as exactly 1. It literally represents 100% of the maximum possible speed in our reality. So if an object is moving at 0.5 in natural units, it is moving at 50% of the absolute limit of the universe. It makes perfect, elegant sense. And if we push the math even further, the whole idea of a limit starts to look a bit different. If we swap out traditional speed for a concept called rapidity, which does a much better job of factoring in time dilation and length contraction, the equations for energy and momentum become beautifully simple. Under rapidity, the cosmic speed limit actually stretches out to infinity. Now, the physical reality hasn't changed. You still can't outrun light, but the mathematical wall disappears. It just shows that our traditional everyday way of calculating speed gets pretty clunky at cosmic scales. So as we wrap up this explainer, let's look at the big picture we've uncovered. The speed of light is not just some random accident of nature. It's born from the deep, hidden properties of the quantum vacuum. It's the engine of causality. It dictates exactly how time flows, how space is structured, and it ensures the logical consistency of everything around us. It is quite literally the foundational code setting the absolute boundaries of our reality. Which leaves us with a pretty thrilling question. If the speed of light is essentially just one line of code in the massive operating system of the universe, what else is out there waiting to be decoded? What other everyday illusions are masking profound cosmic truths? If you're as fascinated as we are by the fundamental rules of reality, make sure you subscribe to the Code of the Universe channel. Here, we take the most complex, mind-bending physics in the cosmos and break them down so they're perfectly clear. Thanks for joining us for this explainer, and we'll see you next time as we continue to dive deep into the very fabric of reality.